Does anybody remember we talked about last week, just for example, like 5 to the negative 2. What would you do with that if you had a 5 to the negative 2? Turn it into positive and what? Sorry. Yeah. So it's division. We talked about why that is. If you have positive exponents, you're multiplying. Of course, if you have negative, you do the opposite. You would divide. So negative exponent means divide. It's going to be the same for variables that it is for constant numbers. The steps are simple. We're always going to be using PEMDAS. Now, with these problems you're getting, there will be no adding and subtracting, okay? There could be, but just to keep it simple, and usually with these kinds of problems, we just don't deal with addition and subtraction. So just remember PEMDAS. You can write it on your worksheet or whatever helps you. I like the fact that you guys are always checking to make sure, can anything be done within the parentheses? And in this particular example, that no, right? Because we have a negative 3, an x cubed, and a y squared. We cannot multiply anything within the parentheses. But next, and by the way, I do have to say this, there are more than one way to do every single one of these problems, okay? Multiple ways. In fact, just right now when we get to the exponent, there's actually two different things you can do. You can either flip this, put it under 1, and make the exponent positive, or you can distribute the negative 4 to each of these terms. It won't matter which way you do it, you're going to get the same answer, okay? But either way, you've got to do something with that exponent. It depends on the problem. If those exponents were negative, it would make sense to distribute the exponent. If positive, you might put it under 1 and make the 4 positive. You get the same answer. Somebody raise their hand? Okay. I'm going to go ahead and just distribute the negative 4 because it's just more consistent. So you're going to get negative 3 to the negative 4.
Wait, how can you do that? How do you do it?
I can do it both ways if you want. Okay, and I will. All right, so then we have x cubed to the negative 4, which would be x to the negative 12. And then y squared to the negative 4, y to the negative 8. Okay, and negative 3 to the negative 4 would be the same as 1 over negative 3 to the 4th. X to the negative 12 is the same as 1 over x to the 12th. And then that would be 1 over y to the 8th. Okay, so negative 3 to the 4th is positive 81. And then everything else just stays like that. So that one's actually pretty simple. You'll see why if you do it the other way, you get the same answer. So suppose for a second that we decided firsthand just to put it under 1 and make it positive. Then it would look like this. Let's use a different color here. It'd be 1 over negative 3 x cubed y squared, whoops, all to the 4th power. Okay, let me kind of divide this so we know we're doing it a different way. So basically what we're doing is just making this positive and putting this under 1. Okay, and you can already kind of see why it works out equally, because now we would distribute the exponent to each of these terms.
So what you did the first time was the second time?
I think it's about the same, honestly. But like I was saying before, if the exponents inside are negative, it makes sense to distribute because it'll become positive. Either way, though, you're dealing with an exponent. It's just different ways of simplifying. So if we do it that way, we end up with the same answer. It'd be 1 over 81 x to the 12th, y to the 8. And the reason it works out is because either way, you're flipping the fraction. You're either individually flipping them or you're flipping them all at once. And remember though, distributing an exponent only works when everything inside is being multiplied. If there's a plus or a minus sign in there, like if it was -3 plus x cubed, we can't do that, right? That's when you have to FOIL the thing out, like we did with the binomials last week. Okay, so you're going to see with this example why it's actually going to be, well, first of all, let's check. Can we do anything in parentheses? No. We really won't get to something like that till tomorrow, but sometimes you might have two x terms inside. You'd want to multiply them, add the exponents. So nothing to do within the parentheses, but here you're going to see why it's easier to distribute, because when I distribute this -3 to the x to the -4, y to the -5, they're both going to become positive. So I won't need to flip it. So if I did it the other way, I'd end up flipping it twice. I'd be doing more work than I need to. Okay? So honestly, I don't really like teaching things two different ways because it can become confusing. But in this particular case, I think it's good to see both ways. So we get 2 to the -3. And then we get x to the -4 to the -3, which is +12. And then we get y to the -5th to the -3, which is +15. So I don't need to flip anything except for the 2, right? The 2 to the -3 is going to become what? Not -8. It'd be 1 over 2 cubed, which is equal to what? 1 over 8. Thank you. Final answer then is 1 over 8 x to the 12 y to the 15. Okay, so again, if you could have taken this expression and put under 1 and made it positive, but you would have had to end up taking those negative exponents and flipping them again. So usually what I do is distribute the exponent. Okay? So mostly for this lesson, all we're actually doing is just applying the exponent, making sure we apply the rules of negative exponents. Okay, any questions on that one? This one's going to be a little bit more involved. Not too much more, though. All right, so the first thing I noticed in this problem, well, I'm going to look to see, can I do anything in parentheses? No. Okay, well, actually, there is one thing I can do. And the one thing I'm going to do is put a 1 right here. That way, when I distribute the exponent, I'll know that it's -1 to the 5th. Okay? So we're going to have, sorry, to the -5th. So we're going to have -1 to the -5th, a to the 4th to the -5th, apply it to the b to the -2, apply it to the c. Okay, so first off, we have -1 to the -5th. Then we have a to the 4th to the -5th, which is a to the -20. Remember, you multiply the exponents. b to the -2 to the -5th is +10. -2 times -5 is -10. And then the c does not have an exponent, so the -5 becomes the exponent. Remember, you can think of that as a 1. So 1 times -5 is -5. Okay? And remember, with constant numbers, you just put it under 1 and make it the exponent positive. The negative stays, whatever's in the parentheses stays. We'll deal with that in a second. So we have 1 over -1 to the 5th. And then that will become 1 over a to the 20. That will remain positive, right? No need to flip that. It's already positive. This will become 1 over c to the 5th. Okay, so what's -1 to the 5th? Does anybody know?
1.
It's an odd exponent. -1. It'll just be 1 over -1, which is -1, right? Then everything else basically drops down. We just have to have one more step for simplifying. So all I'm going to do now is just combine this into one fraction. In fact, the -1 just means I'm going to have a negative out in front of the fraction. That's all that means. So I'm just going to put a negative out in front of there, and that'll simplify that. Whatever's on the bottom, I'm going to put on the bottom. Whatever's on the top, I'm going to put on the top. We've got a to the 20th on the bottom, because it's on the bottom of that fraction. You could actually. That's a good question. You could write that as x to the 12th, y to the 5th over 8, and that would be equally correct. All right, and then b to the 10th is on top, and so that's going to be the answer for this one. And you know what? You can take that negative and you can actually put it up into the top or the bottom. I usually just put it in front. And the last one is actually probably the easiest one. I decided let's just do one. So this one doesn't even have an exponent on the outside. So actually all we're doing is just flipping what needs to be flipped. Okay, there are no parentheses, so we can check that off. Actually, I didn't want to talk about this. Technically, there is no exponent to apply to those, so we can check that off. Certainly, there's no multiplication, and the reason I did this example is because I thought about this for a while, and I realized that when you are taking a negative exponent and you're making it positive and flipping it, you're actually dividing. Okay, so in this particular example, the only thing we're actually doing is going to be dividing. Okay, so right off the bat, we can just rewrite -12 x to the 5th because there's nothing to do with that. There's no steps to take. Only thing we have to do is flip that and put it on the bottom, and then flip the z to the -12 and put it on the bottom, and that's it for this example. So I think that the best way to categorize flipping a negative exponent, putting on the other side of the fraction, is dividing. And that's it.